Uh, Very good evening, everyone. Hope I am audible. I am Engineer Suran Fernando, Chairman of the National Engineering Heritage Forum of ISL. And it's my pleasure to warmly welcome you to this public webinar organized by National Engineering Heritage Forum. Today, we focus on the role of modern technology in the preservation and exploration of Sri Lanka's national engineering heritage. As NEHF, we are committed to introduce state-of-art technologies to heritage conservation efforts. Recently, we conducted a LiDAR drone survey at Ranmasuyana Ancient Pond Complex in Anuradhapura, one of our key initiatives in leveraging advanced tools to heritage research. Additionally, we are working towards incorporating cutting-edge technologies into the National Engineering Heritage Pavilion at the Colombo National Museum, ensuring that the ancient engineering marvels are effectively demonstrated through modern means. In this context, it is essential to understand how modern technology backed by data analytics can enhance heritage exploration and preservation. To shed light on this, we have the perfect speaker, Engineer Dr. Sandun Dassanayake, the task leader of the Heritage with IT subcommittee of NEHF. Dr. Sandun Dassanayake is a senior lecturer at the Department of Decision Science, University of Moratuwa. His research focuses on AI-driven analytics and spatial data science, effectively integrating GIS, remote sensing, and machine learning to tackle complex challenges in sustainable urban development, environment assessment, and geohazard prediction. He has also played a key role in postgraduate research governance training programs in advanced analytics, and currently serves as the Director of Postgraduate Studies at the Faculty of Business. His extensive experience, including previous research roles at the University of Warwick, UK, Monash University, Australia, has equipped him with expertise in cross-functional research initiatives, international collaboration, and research management. Without further ado, it's my honor to invite Dr. Sandun Dassanayake to deliver this webinar. Dr. Sandun, the stage is yours.
Thank you. Thank you, Engineer Suram, for this very nice introduction. So let me begin with opening my camera. Yeah, so hi, everyone. All right, so let me share my screen first, and I hope everyone is comfortable at this time. So let me share my screen to begin with. All right. So unlike a typical webinar, I expect some interactions from you. So I hope I'm not troubling you too much. So if you are in front of a computer, please try to join with when we ask you to interact with the presentation. And if you are not in a position to do so, it's totally fine. All right. So without further ado, let's, I think Engineer Suran gave a very good opening for our discussion, what is in heritage informatics. So I titled this presentation as Heritage Informatics because it's an emergent field, and most of the things that we do in the National Engineering Heritage Forum overlap under this category. So it's like a large umbrella where you have part of it as heritage informatics. So I hope this is going to be something that is enlightening, and let's go forward.
Dr. Sandun, 1 second. Your presentation screen is displayed. If you can make it full screen, that is better.
Right. So let me change. Okay. I hope now it's clear. Okay. I hope now it's clear.
Yeah, now all right.
Thank you. Thank you so much. Right. So as I said, there will be some interactions with the audience. So let's begin. Right. Now, my presentation, I have outlined it as starting from the background of what we are going to discuss, and then what is heritage analytics, because I opened up with heritage informatics, and now I'm going to talk about heritage analytics, and then methods of analytics, and then some strengths, weaknesses, and opportunities in the Sri Lankan context, with some indications about the threats when we are trying to implement this strategy. All right. So let's begin with the background, but I need your assistance here. Please, if you are in front of a computer and you have your mobile phone, scan the QR code, or please visit slido.com from your mobile phone. Right? I'll go to the next slide, and you will get a chance to give some opinion. And that is important. So please, if you are in front of a computer and you have your mobile phone next to you, please try to help me out. So if you are also seeing this screen, you can visit slido.com and then join this poll. So the question is, when you hear engineering heritage, what comes to your mind? And it doesn't matter, it should not be a very short answer. Also, you can be explicit and mention what you feel when you hear the word engineering heritage or heritage as a whole. You can scan the QR code, or you can go to slido.com and enter this number 6033 191. So we got the first name, Alla. So that's great. Thank you. Others also, you can chip in. Ancient building or any other structures, ancient engineering, exploration of the past, preservation of the past, Ruan Valisaya, ancient construction, engineering artifacts and systems from the past, engineering aspects from the ancestors, something we haven't given much consideration but should give. Okay, that's great. And okay, we are getting new prompts as well. Let's see, couple of minutes. Ancient construction, engineering aspects from the ancestors, ancient engineering, ancient technology. All right, great, thanks. So I think we got a gist of what's there, and it's great because this is exactly what we should be looking at: the diversity in the expert community as well. Like, people look at heritage from different angles, as we are getting more and more inputs now. Historical wonders, ancient engineering, how design, construction, planning done, materials. So as you can see, even though we name this as engineering heritage or cultural heritage, it's really vast and broad, because you can start with the materials and end with the constructions, or you can start with the architecture and end with the landscape planning or art or anything that is related. Because when there is a history, you can always find something, some culture, some knowledge body associated with that. So excellent. Thank you very much. So let's go to the next slide, because with this, we can actually move forward with our idea of heritage. So the definition, the most used definition for cultural heritage is, it's not just about preserving artifacts, it's about collective remembering. So whenever we remember a certain body of knowledge or certain way of life, we commemorate a heritage, or a culture is born out of it. And okay, so there's another comment saying it's nothing very ancient, but limited to somewhere 17th century and after. So as I told you, a culture or a heritage or cultural heritage as a whole is actually a collective remembering of things. It doesn't matter whether it's going to be ancient or recent past. It's all about forming a sustaining identity about some group. So it can be an ethnic identity, it can be a professional identity, like when we talk about engineering heritage, or it can be anything related to as such entity. So to make our lives easier, we have divided this under 4 subclasses. When we talk about tangible artifacts, which is about information as thing, we talk about machines, blueprints, the architecture and the buildings, as you have mentioned in your response. Also, we think about machineries when we think about tangible objects. And then we have something called internalized knowledge, which can be a practice. We can say collective wisdom, principles, and documented experiences that inform about a certain practice. So it's easy to look at this from agricultural engineering perspective. Like in Sri Lanka, we have a certain know-how about how to do our paddy fields, how to do our things. There's a rich culture behind it. So it's an internalized knowledge, and it's information as knowledge. So it can be about how weather patterns change, how certain seeds should be planted, anything of that nature. And then you have dynamic processes where you have methodologies and problem solving approaches that is there. Like even there are certain cultural dances that contain knowledge, like how to do a certain thing, and you have a dance out of it. And then there are art, some artifacts like drawings, etc., that also is embedding a process inside that, how to do a certain act. So information as process is also there. And then we have this collective memory and identity, which is essential when we look at the digital identity of heritage, because we are trying to create an information entity, a memory, and an identity about our past. So anything can be considered as engineering heritage in this context, because whenever we talk about a history, about a process, about a thing, about a knowledge, we are trying to replicate it or preserve it or try to learn out of it. Can be about the processes, how to improve them, how to optimize them, and how to use them in our everyday lives, and how to preserve them for the next generation. So as a thing, as a knowledge, as a process, or as a collective memory and identity, we are looking at the past. So that's engineering heritage. So in this context, I recommend you 2 books that are really closely following what we are discussing here. One is History of Machines and Manufacturing, and the other one is History of Mathematics, which in my opinion, the first one talks about this machines and manufacturing. So it's written by Dr. Chandra Javadar, another member of our Heritage Forum. So the way machines and manufacturing happened in Sri Lanka, because when you look at the constructions, about the past constructions, the buildings, the architecture, there should be some machinery behind it. There should be some tools behind it. And that's also heritage. Information as thing, information as process, information as knowledge. So that is a very interesting read. And also History of Mathematics, where we talk about the knowledge, how collective memory and identity, the identity itself, being a person who create something, an engineer, how mathematics, the skill of mathematics was used as to symbolize this ability of a person, and how a profession is created out of it. You can actually get a good idea about that as well, referring to our ancient knowledge, not ancient, as someone said, history, let's say. So look at engineering history from a different perspective. All in all, the important thing is you can look at the past from different angles. And when we do that, I want to emphasize this fact. So we have engineering disciplines like chemical engineering, civil engineering, computer science and engineering, mechanical engineering, different disciplines developed just because after the industrial revolution, or because of the developments, we need different disciplines for our everyday activities. Because of that, the disciplines were created. But that doesn't mean these disciplines existed many years ago. So when you look at uh, these things from the past, the heritage from the past, you would need multidisciplinary approaches, cross-disciplinary thinking, and different paradigms to look at these heritage from different perspectives, then only we will be able to preserve engineering heritage. Then only we will be able to understand what is actually engineering heritage. Right. That being said, let's go focus on the requirement of heritage analytics. Now, we look at heritage as a body, as something that exists as an information body. So what is heritage analytics? Why should we analyze heritage? Why should we analyze the information related to heritage? Now, if you now I did some research for you so that I can compile this one, and also to make sure that we are on the proven track of knowledge creation. So when you look at domains and disciplines that have focused on heritage analytics over the past couple of decades, let's say 1985 to 2021, you can see a huge number of publications being created by computer science domain. Because when we look at heritage as an information subject, heritage analytics, you look at digitization, you create computer games sort of environments about this past, and you have engineering, medicine, of course, and mathematics as an ancient or an old subject area, and then the other things follow. And also, if you read about the writings, you would find that accounting was the domain area that was the reason behind the modern writing, how people started writing and keeping information, because there were some businesses happening and the accounting was the reason. So as I said, it's a multidisciplinary thing. And if you look at the domains and disciplines, you can see heritage analytics, the information analytics about heritage has been widely spreaded, and it can be found in many areas in the modern subject domains as well. So of course, in the brevity of this discussion, to make sure that we have some tangible outcome out of the presentation, I listed down three main criteria that should be discussed when we look at heritage informatics, and why we should look at heritage analytics as a whole. The first thing is climate change. Because if you look at climate change, the impact of climate change on the structures as a whole, the structures that were developed even 20 years ago, you would understand how it is impacting on the sites, or the artifacts that were actually maybe 100,000 years ago, or 1,000 years ago, sorry. So that is a major reason why we need to analyze heritage in modern, using modern technology, because climate change is reaching us faster than we expect. So every 2 year, 3 year, we are seeing extreme cycles of change, and that is impacting on the climate, on the artifacts and the heritage in large scales, and in large impact is there. Then you have natural hazards. So of course, one can argue the climate change and natural hazards are very closely linked. But if you look at the black swan events, we call them black swan events in the climate change domain. Black swan events are those events where you don't expect it to happen, but it happens, and only when it has happened, we realize that the magnitude is very high. So like tsunami, like pandemic. So there can be many things. The magnitude is very high, the impact is very high, but they rarely occur. So that is also included in the natural hazards area. So you have climate change, natural hazards, and then of course anthropogenic activities like civil wars and urban expansions, industrial pollution, all the bits and pieces where humans interact, or human activities create different impacts on cultural heritage. So climate change, natural hazards, anthropogenic activities, all these things, all these criteria collectively impact, also separately impact on heritage. So that's why we need to analyze how they impact, how they interact, and also whether we can mitigate these issues and focus on any potential interventions that we can make to reduce the adverse impacts, also to improvise and improve the positive impacts. So that's the idea of listing these three. Right. Now, let's try to map climate impact with the Sri Lankan context. So, although the freeze and thaw cycles are not relevant to Sri Lanka at the moment, but look at the concerns related to climatic stresses and non-climatic stresses. So when you look at climate stresses, the major three climatic stresses that are impacting on the heritage sites are temperature, precipitation, wind. So the plus and minus indicate it can be the increase of a certain parameter or a decrease of a certain parameter. And the bold lines here, freezing and thawing, thermoplastism, corrosion, biological growth, salt crystallization, material erosion. These are like the macro level characteristics of the impact. So if you look at corrosion, for example, corrosion as a concept is there. So you corrode a certain surface because of oxidization or something like that. So that is the action of it. And then you have the resulting examples. So if you look at Sri Lanka, most of these impacts are related to Sri Lanka. For example, structural damage of building materials, because most of our heritage sites are either stone, monolithic structures, or brick. Ceramic materials can be there also. And then you have micro cracking of stone because of cyclic temperature variations over the years, and the varying degree of temperature variations, because maybe there are experts who are working in the material sector who are looking at these cyclic interventions of temperature or pressure. You know that because of the differential pressure expansions, there can be micro cracking that can lead to severe structural failures as well. And then you have exfoliation of stone because of different conditions. I don't need to go into the details of this, but what I'm saying is, because we are a tropical country, we experience temperature, we experience precipitation, and we experience wind. So these three climatic stresses are seriously affecting our cultural sites and artifacts and things that we want to preserve. So how do we link in analytics to this? So obviously, when you look at climate change studies or climate impact studies and heritage studies, they may be isolated and further apart, like two islands. But if you carefully look at it, they are actually linked. So the main idea is there is a link between these two. The only thing that is missing is experts and people like you who want to look at it and then study it. So the studies are scarce, but this is it's ongoing and this is emerging. And a lot of people are doing this because heritage, on the other hand, is linked with the economy, the tourism, and many other things, the identity of a country, as I mentioned earlier. So these are there, and the need of analysis is there. So non-climatic stressors, if you look at pollution, acidification, acidifying pollutants, when they interact with the moisture of the surfaces, you know that people, when they go into the heritage interior, there will be a lot of people inside, like tourists, and because of them dwelling inside, the inside relative humidity is going to increase. So with the moisture increase, the acidification is increased in the moisture, and that can impact on the paintings, on the interior. If that is the material is reacting with the moisture, that also can be a fact. So many things are there. So just shedding light on very important points so that you can actually think further. And as a whole, now, if you look at natural hazards as an impact, you can see what UNESCO says about this. So 1/6 of cultural heritage properties, so that's around 15%, like 12, 15% of the heritage properties are under threat from climate change externalities. And 1/3 of the things are actually near coastal, or actually, if you look at the ancient civilizations, they are very close by to the rivers. So flooding is a major threat as well. And of course, there are vulnerabilities all around the world. because of urbanization. And if you look at Himalayas, the glaciers are melting. The wildfires recently, you saw what happened in New York, in America. So many issues are there, and they are very diverse and broad, and one person cannot really pinpoint what is happening. The only thing is that you need to have a collective entity studying this, or cross-disciplinary and multidisciplinary interventions to actually understand what's happening. And coming, focusing on Sri Lanka, I have listed down 8 Sri Lankan heritage sites. To the right-hand side, you can see sacred city of Anuradhapura, ancient city of Sigiriya, and so on and so forth. And of course, to the left-hand side, you see some news articles. Of course, I just selected a few out of the vast majority of available such news. But what I wanted to highlight is that if you look at Venice, Venice is prone to flooding. And if you look at Pakistan, Pakistan may not have experienced such extreme floods earlier. So the the variations of these impacts are really threatening, because we don't know what will happen next. Now, if you come back to Sri Lanka, all these 6 events that I have noted here: floods, landslides, cyclones, lightning, coastal erosion, and tsunamis, they are impacting Sri Lanka. So tsunamis, as I said, it's a black swan event which can happen very infrequently over a large period of time, but the impact is really high. And coastal erosion, of course, we have Old Town of Galle, which is a heritage site, and the coastal erosion that comes from the tidal waves that is impacting on that nodal area, can increase the coastal erosion of Galle Town as well. And not only that, lightning. I mean, many people do not think that lightning is a serious issue when it comes to cultural heritage, but yes, because most of our cultural heritage are located either in the mountains, in a top area, in a highland, or located to an urbanized area where you have this lightning issue as well. So if you have done any study related to lightning, the impact of lightning, whether they are impacting the heritage sites or the areas per se. For example, if you look at the severe lightning advisory for Sri Lanka in the previous 2-3 months, you can see, in fact, the red area is rightly overlapping with the 8 heritage sites that we have here. So that's a serious issue for our heritage sites as well. And cyclones, and if you look at the access roads and the areas around them, they are severely affected frequently and infrequently by the climate hazards as well. So, but the issue is, the studies related to climate analysis or hazards and the studies related to conservation of heritage, they are further apart, but they have a huge overlap between them that needs to be studied. Now, let's go further with some historical accounts about the anthropogenic impacts, particularly looking at Sri Lanka. So this is also part of analytics, where we look at historical events and how like it can be text analytics, sentiment analytics, where we look at the past and to see where that major shifts in the culture happen. Now, this is taken from Destruction of Cultural Heritage in Sri Lanka from a paper. But if you look at the thematic analysis of it, you can see how indigenous religions and the political gains and the erasure of historic monuments, this is the same thing that has happened over the past. So you can analyze these things, because when you look at history, it's a very vast ocean of information. So you look at that body of knowledge using text analytics, modern analytics tools. Right. So I think that sets the pitch correctly to talk about methods of analytics. And as I said earlier, I actually tried to minimize the information and try to make sure that we can memorize things after the discussion. So not to go boasting about many things that are possible. So I clustered them under 3. One particular technical intervention in terms of analytics is monitoring and pattern or feature recognition, which is very commonly used. And you have digital preservation, where you preserve some structure or some color or something related to that heritage site as a digital entity. Nowadays, you have NFT markets as well. Because this is not related to NFT, I'm not going to talk about that. And then you have data fusion techniques, where you combine multiple technical interventions to achieve one preservation task or analytical task, so that you can relate to the preservation or the heritage analytics as a whole. And out of like inside these three, I have seen the techniques, the technologies that are listed as points. So you have light detection and ranging, LiDAR, photogrammetry and 3D modeling, CT scanning, digital image processing, virtual reality and augmented reality, VR and AR. I think VR and AR, most of the time, if you are familiar with the games and modern technologies associated with that, you know what is VR and what is AR. So they are also now in the heritage part of things, because tourists enjoy using them, and also the visitors, they get more information out of that VR and AR. So we have 6 such technologies that I have listed under these 3 main clusters. So let's look at the first thing, that is related to monitoring. So this is our LIDAR survey, as Engineer Suran mentioned at the very beginning. So we did this last year for the Ranmasu inner site. So because, as I believe, there are people not from civil engineering domain and not from survey engineering area as well, so spatial engineering side. So I will just give you a bit of a brief introduction about the technology used here, so that it's easy for everyone to understand. So what we have is, we have a platform, drone, and the drone consists of, if I just draw my cursor, so we have a drone here, and the drone is our platform, and the drone has a LiDAR sensor, which is a light detection and ranging sensor. It is connected, and there is some technical process behind it. Once it is connected, we need to regulate its movement. I'll go to the next slide so that I can explain it. So the platform will have a roll, pitch, and yaw. So you can understand when the platform is moving, like a drone, you have either rotation in one axis, because there are 3 axes. The yaw, roll, and pitch causes the imbalance, the platform to have multiple orientations. So we need to regulate that first, calibrate it, and then we put the sensor, and everything is connected with the global navigation systems, GNS, GLONAR, or GLONAR, whatever the global GPS system that you are using. And then you have the survey path well defined earlier, and the drone is following along that path. So what happens is, very simple thing, you send a light beam and you collect the data to understand the roughness of the surface, so rather the topology of the surface. So what happens is, the number of measurements you take at a given instance is very high. Because of that, you have a point cloud, not a simple set of points. You get a point cloud with the X, Y, Z details. So you can actually create the topology of the entire surface. And that is the beauty of LiDAR. Because if you are doing a survey, particularly in concern with heritage site, you don't know where to do the survey, and maybe you are seeing one particular aspect of the area, and you may be just looking at that aspect. But when you are doing a LiDAR survey, you can look at this helicopter view of the area. While looking at the helicopter view, you can actually generate the cross sections, the heights, the topology of the area. So that can reveal some artifacts or underlying structures, things like that. So that is the beauty of LiDAR. And LiDAR existed maybe 5-6 years ago, 7 years ago. LiDAR was a thing in Sri Lanka as well, because it is used in survey. But LiDAR the use of LiDAR in heritage or in archaeological excavation, exploration is new. So that's the beauty of heritage analytics. You combine multiple domains and try to look at the heritage from different angles. And let's look at the next one, which is related to our work, which is related to Ranmasuyan. These are ongoing analysis, and of course, because everyone involved in the project are not 100% in the heritage forum all the time, so we are progressing, but bit slowly. Anyway, the thing is, we are developing the cross sections of the Ranmasuyan profile or related aspect of that area. So why do we do that? If we can create something like this, we can create a database of knowledge, database of information where we have the lengths, depths, or the measurements of different archaeological sites, so that we can actually link our engineering knowledge or the way they were created along the timeline. And if a certain measurement type, certain way of construction can be identified using the measurements, we can actually cluster them based on their ages, based on their eras, and so and so. So there are a lot of things that we can do with it. And also that's one part of actually looking at the archaeology of it. And the other part is, of course, conservation and trying to see whether there are threats involved around the area that destroy this heritage site, or how to preserve it in different ways. Maybe the rainfall is causing damage to a certain area, so and so forth. So you can actually look at it from a macro point of view. So just to enlighten you with the ongoing work, I just put this slide here. Let's move forward. Now, this is interesting. So there's another link. I have shared this link with I hope the someone is going to share this link with you. This is Kantharaday expedition. So this is not related to what we did, but someone else has done it. So this is related to photogrammetry and 3D modeling. I would like you to see this. So let me click on this and show you what this means. So this Kantharaday expedition was done by Associate Professor Robinson from Sydney. So what happened here is you get multiple images around an area, and then you overlay those images in a way that you can create the 3D structure. So if you have more images, you can create the 3D surface of an area easily. So if I take a photo like this from one angle, and then take another angle and take a photo of it, so we call this oblique photogrammetry. You take a different photo out of a different angle, so and so forth. If you keep on doing it, then you create a cluster of images of the surfaces. Then it's an extensive computer algorithm where you combine these 3D surfaces to create the 3D structure of it, where you see it, right? There's a difference between LiDAR and the photogrammetry. There's a part of photogrammetry used in LiDAR. That's for the coloring of the surfaces with the RGB image. But here what happens is you take a photo and you create it as like an art piece. So there are no measurements. Of course, you can measure it. The technology is evolving. But what I'm saying is, in general, you have the 3D view of it. So you don't know the measurements or anything as such, but you can look at the area like you are there. So that these are the building blocks of modern VR and gaming engines. If you are interested in those things, you can check that out. So that's a macro level conservation, macro level preservation of a site. But if you look at an artifact, for example, if you are an archaeologist living somewhere far away from Sri Lanka, and you want to collaborate with a Sri Lankan scientist, then sending something like this would be like a good discussion point, because then you can zoom in and look at the texture, surface, and also the text on the surface, so that before even you reach that site, you can come to some idea. You can brainstorm. You can share ideas, views, and thoughts about that artifact because of this technology. So it's a 3D modeling technology, 3D photogrammetry, and you can find many examples as such from these sites. Sketchfab contains a lot of such details. You can actually go and check that out, right? So let me go to the presentation. Right. So as I said, process of digitally recreating landscapes, buildings, and objects, combining the images. So that's one type of analytics. So this is one of my favorites because this is actually the reason why I was interested in the first place about using analytics for the heritage. Actually, this was some news item that I found 5 years ago, where you have this challenge. So I got to know about this challenge, and I learned that the pay is really good. So you get a good price for if you can decode what's there. So let me show what it is. This is called Vesuvius challenge. It's a very famous challenge. So what happens here is, because of an eruption of a volcano, and a library was entirely destroyed, but you can find the scrolls inside that area, right? So you can, what they do is they use CT scanning to unwrap it digitally. So you have this CT scanning where you put the scroll inside the CT scanner like you do in a medical lab, and then you scan the scroll, and you can create a 3D structure using the CT scanner, and then look at it, then try to see what was written on the scrolls. Because of the differential density of the ink, you can see that the scroll. So you can actually visit this website and see how the generation of the fonts and how they were identified using CT scanning. So it's a very interesting project. This is actually this was the project that got my interest as well. So it's very interesting, and if there are ongoing challenges, there are 60,000 or more scrolls available. Different research groups are actually looking at how to decode these. There are winners and there are prizes as well. Then there is an ongoing prize for another scroll unwrapping as well. So it involves a lot of technology associated with computer science, image processing, CT scanning, feature engineering, data mining, many things are there. So if you are interested in, you can go and check as well. And right, go to the presentation. That's VCVS challenge. And that is about CT scanning. So CT scanning, this is just one example because it's really fun and rewarding. I shared it here, but there are other options as well. There are a lot of things associated with CT scanning where you combine machine learning, AI, CT scanning for such activities. And last one about data fusion, because many kind of find it difficult to grasp what is data fusion. So data fusion can be many things. One thing is you create a photogrammetric 3D image and then use some other detail to combine. So that's fusion. So I just shared a research paper here where they have used Twitter sentiment analysis or tweets that happen inside a city to identify the ecosystem services in that area. So the applications are many, like you can use social media, community data science, community data collection algorithms to find this and show how a certain site is responding. So it can be Sigiriya, it can be Siripada area, it can be any other area where you use data from social media, combine it with different sensors, and show this impact. So that's data fusion. Right. Okay. So let me go to the presentation. Again, something happened. Sorry for that. Something happened. Right. Right. All good. Right. Where were we? All right. So the last bit about virtual and augmented reality. This is also available in Sri Lanka with the Polonnaruwa Museum visit. Uh, National Engineering Heritage Forum also had a visit there. There what you get is you have a database connecting you with the information available inside that area. So that's also part of digital recreation, digital preservation. So if you want to see, if you want to know more about a museum object or something, what is the history, etc., etc., you can scan that QR code, or you can put on those VR glasses and then immerse, get the experience inside that area. So that's very common and modern technology, which is very familiar to if you are going to 3D movies and things like that. So that is there. Now, collectively, we discuss about different facets of this cultural heritage analytics, starting from how to collect and monitor data and how to analyze the data, then using CT scans, how to go into different domains, starting from macro level, like 1 kilometer, 2 kilometer range, all the way up to micrometer, nanometer scale, and then you look at also creating digital spaces as well. So the possibilities are endless, and you can think of many other aspects of it as well. Now, my last concern is about whenever we look at something like this, something novel, we need to look at the strengths, weaknesses, and opportunities that is available for us. Now, if you look at Sri Lanka, we have a, a huge strength in our heritage because we are known as a destination where heritage sites are available, and we have a very rich history of engineering heritage and also cultural heritage as well. So we need preservation techniques, digital preservation, knowledge management systems, because major part of our economy is also run by this. So it's a strength for us, and we have the backing. So because of that, you and I are here discussing about it. So that's a strength that we have. But in terms of weaknesses, what I see is, because the cost associated with these techniques are a bit high, and also the skills required to do these things, we are a bit lacking in that department. So that's somewhat a weakness, but I hope that in the future, when the interested parties gather, there would be a huge interest in this area, and also the financial constraints will be also gone when such uh, enthusiasm is built. And when you look at the opportunities, there are a lot of new technologies coming. And even myself, I'm working on the citizen science and crowdsourcing technologies as well for disaster management. So I see the potential of using them for heritage preservation as well. So there are many people who are working in this area, and there are opportunities because heritage tourism is a major industry, and you can actually combine a lot of scientists, a lot of enthusiastic people who would be funding these projects. So there's an opportunity around it in sustainable tourism. And also, the most important thing is, whenever you combine advanced analytics into heritage preservation, as in heritage analytics, you are combining multiple technologies. So not only heritage preservation, that can also lead to any other management services or facility management services or disaster mitigation services as well. So that's an opportunity that is there. So threats, of course, there are climate risks, and you obviously have experienced what happened with the Sri Lankan national grid yesterday. So there are wildlife cases as well. So if you put a sensor somewhere inside the heritage site, then we don't know what will happen next day. That threat is there, and also certain encroachments, urbanization like urban sprawl or development pressures that are happening, that are trying to take control of those areas, then actually maybe the threat levels are increasing. So the smoke, the air pollution, increasing those kind of threats are there. So they are uh, fastly moving as opposed to our intervention. So that's a major threat that I see. And the vandalism and unregulated tourism, this is a serious issue because when you try to regulate something, there would always be some other issues. Like if you are trying to put a digital trace of what is happening in a heritage site or trying to preserve it, there would be always some other issues coming maybe from the surrounding and the society associated with that. And lastly, it's mainly technical, where when you are trying to preserve the data, there is a, so as I said, I come back to the very first point that I said, what is heritage? So heritage is a collective memory. And this memory, if someone is altering this memory, then we are retelling a different heritage. So the cyber security risks associated with how we are going to preserve our history using digital technologies, that thing is there. Because if someone is going to alter that history from our record books or change it, then actually we are remembering something that was not ours. I think you all understand what I mean by even with a historical story, people can develop characters out of it. People believe in a history that was not there. So preserving history as is a serious challenge, and it also involves a lot of technological interventions as well. So all in all, heritage analytics is a modern field. It requires multidisciplinary and cross-disciplinary interventions, and a lot of skills are needed, and technology is there. Only thing is that people with different skills need to look at the problem, for the same problem holistically using different technologies. Then only we will be moving forward with this current trend of heritage analytics. So that's about my presentation. You can follow the same QR code, the QR code that's on the screen, or the link that is there, and we will have a Slido Q&A session as well, so that I can see your question. So you are more than welcome to post a question on the Slido platform. Then we can see the anonymous questions, and it's easy for us to interact. Thank you.
Dr. Sakura, you can take over.
Yes, yes. Thank you very much, Dr. Sandun. I hope if our audience are they using the link you shared?
Yes, there are one question.
Okay. Yes.
So hopefully there will be other questions as well.
Just so till then, I will go through the chat box,
Yes, sure,
Zoom
please.
chat box. So the and then I will follow the order that they have. Some have sent direct messages to me, and some are already. Dr. Sandhu, no, you also can view.
Yes.
Yes, yes. Okay, so
Okay.
the first one actually, I will start with the first one. So, how does the LiDAR technology help in preserving Sri Lankan's engineering heritage, and what are the main advantages over traditional methods?
All right. So I think in general, what I see is that there are a lot of sites that have been surveyed in the past. So we don't know, maybe the erosion issue might be there, and there can be other issues. And also we are not sure of whether the records that we have are actually accurate. So with LiDAR, it gives us the opportunity to look at the area from a broader perspective. So if you look at recent articles about what LiDAR opened up in Peru or other parts of the world, we never know that there can be other traces in those areas where we haven't looked at. So if you use LiDAR, we can look at the area from a very broad perspective, and we can connect the dots. So there may be ancient cities where urbanization has took over that area, and the part of that ancient city is missing. So if you do a LiDAR survey, you might not be able to see a link there. So I think LiDAR is an affordable technology now. There are a lot of the platforms are there. The issue is with the sensors, if you look at it. But I think we can incorporate LiDAR from a holistic point of view to get more information, plus actually get new insights out of that. So I think that's a plus point for Sri Lanka.
Okay, thank you very much, Dr. Sandun. The next question is actually it is about that our society is ever evolving given changes in language, living styles, human requirements, and etc. So, does the built environment in that context? Why should we stick to the past? It seems to me that we tend predetermine we tend to predetermine that the past was more sustainable. Is it pre-assumption valid?
Well, such presumptions are only valid based on the discussions that we hold it on. So sometimes we can believe on a certain prejudiced past where there is sustainability, and then we argue that, look, there was sustainability and now it is not there. But the question is, what is sustainability? So as the question itself says, our society is ever evolving. So the concept of sustainability is evolving. So in the past, if you look at certain civilizations, information was the most valuable thing. If you look at Arabic civilization, the Arabs, the Iraq, the information was the gold there. So there were nothing about waste management or anything as such. It was about algebra, creating gold out of material. So that was the concern in that civilization. And if the question has multiple facets, as I see, one thing is, why should we stick to the past? Because we are a civilization. So we are linking the past to the present and to the future. So if you are speaking a certain language, that's because in the past, there is a logical articulation or logical construction of the language, and then we are sticking to that past to create new information here. And maths is from the past. So if you are looking at prime numbers are there in the past, and the prime numbers are here as well. So if you are looking in the past patterns, only you'll be able to understand in the future whether there are patterns as such. So I don't see why as a question. I think we should look at the past, because as a civilization and as a human being, we have a very short lifespan. So maybe I'll be living maybe 70 years, 60 years, hopefully. So after that, what will happen? The next person needs to build on the shoulders of the giant in the past. So you have to look at the past in order to create the future. That's the answer to the first question. So it seemed to me that we tend to predetermine that path. I don't think that we ever prejudice a sustainable history. All right. What we do feel is that there were techniques that were more blend with the nature, because the technological complexity was limited, maybe. They were using hydraulic engineering for lifting material. That was the only thing that they were doing. So maybe some other might be using technology to create structures on the monolithic structures. So those are maybe those two technological interventions, maybe 200 years apart. We look at it from now. So we see them as a single lineage, right? So it's not sustainability or as such, or a marvel or as such, but they were 200 apart in the history, years apart. So we need to look at this. Otherwise, we don't know what we are dealing with as a species. So that's my understanding about the question. So the second question I can see, what is our final target after all this study and site visit? Whether publish or only article, report, improve. Right. So to answer this question, I believe that just research publications are not enough. So nowadays, science is moving forward from H index or I-10 or those things towards more impactful research. So I feel that without even having a knowledge body, it is not our place to articulate such an argument saying that what is the purpose of this. So if and only if we can create a knowledge body, then we will be able to use it. So how we are going to use it? It's not a single man's concept or an idea. I think once we create the knowledge, then people will come and people will try to use it in different ways. So who knows? Sometimes it's for heritage tourism. Sometimes it may be for medicine. But only if we create a proper knowledge body, then I think that will be useful. So how we create it is the issue. Is it from research papers, presentations, webinars like this, or national? Because a sensitive matter like this is very difficult to be introduced to the public as a whole. So it has to come through very delicate and sensitive channels in ways in which you can actually explain what is happening. So that takes time, like history. So I think it's not the place right now to argue what is the purpose of this, but I think we can build on it. No clear sound. I'm sorry for that. Maybe your internet connection might be connection issue. I think others might have heard me, hopefully. So අපේ සංස්කෘතිය ගැන සිංහලෙන් සාකච්ඡාවක් පවත්වමු. Okay. So uh, sure. I mean, it's up to the organizers. Let's see. Thank you for your, okay. Thank you. Right. Thank you. All the others are thanks. Hopefully.
So, Dr. Sandun, there is
Yes.
another one. Is it feasible to employ heritage analysis for examination of track propagation in the Jetavanaram Stupa?
Yeah, absolutely. I mean, you just you basically, as I said, it's a subject where I have cross-disciplinary and multidisciplinary intervention. So if you are going to use structural monitoring techniques, like you have bridge, if you have a bridge, you have the mechanism to find out whether there is a structural failure, track propagation, or anything like using technology. So, but the problem is the technique should be non-invasive. So most of the techniques that I have discussed here are non-invasive. LiDAR is non-invasive, and photogrammetry is non-invasive. So yes, so if you incorporate any other inverse modeling technique with maybe if the crack propagation is going to create thermal anomaly on the surface because the material is not connected, then perhaps using a thermal imaging plus some point cloud analysis might give an indication about whether there is a crack on the system. But crack propagation is a serious concern. There are laser measurements that are there, but to check submillimeter movements, it will require some good analysis and research. I would say some holistic view rather than a simple question. But for answer, yes, it is possible, but it requires some good understanding of the problem. Right. So.
Dr. Sandun, we have two questions in the Slido.
Yeah, Slido.
Yes.
So first one, thank you for the comment. The second one, has any project taken over into it producing and displaying augmented reality for heritage sites, very common around the world? Yeah, there are some projects happening. So I'm not involved in the project, so I cannot comment on them. But as far as I know, there are a few projects going on displaying augmented reality for the heritage sites. Has data fusion using emotional tags from social media been used already in heritage-related projects in Sri Lanka? So I have no idea because as far as I know from the international papers and other things, there are some sentiment analysis happening. But regarding Sri Lanka, I couldn't find many. I was not focusing on that area when I did the digging, but I haven't come across anything as such. So there's another question.
Yes.
I have okay. Now I'm working in data science. What are your thoughts on in maritime archaeology? So well, I think it will be a broad question, right? But I think as far as you are interested in, that's kind of good.
There's another. And another and Slido.
So, okay, LiDAR.
Yes.
LiDAR could be used for heritage site preservation as in deterioration observation. Well, LiDAR as a technology is like a knife. So you can use the knife to cut a cake or to cut a to create nice architecture or something, or cut a tree or anything. So it's a technology. What happens is you monitor the site and you create a point cloud. So that point cloud can be analyzed in multiple ways. It can be for surface deformations, it can be for the sites, other areas and stuff. So yes and no, because site preservation and deterioration observation would require uh, what we call two different images of time. Because if you are going to observe the deterioration, you need to base it on something else, right? So you need to create a base image and then observe it afterwards. So it's a tricky question. You can use it for preservation, like you have the data and you have it in the digital form. Yes, it's a there are some other complications as well. But for deterioration observation, if you know the previous site and then observing the data would reveal something out of it. But it's I don't know whether it's really, I mean, 100% accurate or not. I mean, using two, yes, you can. Uh, two images in time scale only means, I think T1 comes in the past and T2 comes in the present. Then you can observe it. Like LiDAR is just for measurements. There are other techniques which I didn't discuss here. That is called informametric SAR is there. So INSAR can be used for this sub-millimeter movements. So most of the issues, the crack propagation issue as well, you can use informametric SAR for that. So there what happens is you use synthetic aperture radar devices where you have the difference between the phase angles, and then you check what happens with the subsidence or the movement. So that's INSAR. That can be better used than LiDAR for this particular application.
So, Dr. Sandun, there is another in the chat box.
Yeah, about the images taken can be composed exactly with a current image. I think it's possible in that. For anyone who is working in the image processing area, they can look at it. It's possible, but I can't say exactly how. You can correlate the current RGB images and see.
Dr. Sandun, I have a question that
Yes.
about regarding the SWOT analysis you have mentioned. So, is there any immediate steps that we can take to overcome the data fragmentation, and like any limitations of the technology? So what kind of limitations?
Okay.
Yeah.
So, right. So when you look at the limitations, as I said, when we are preserving something now, we maybe our LiDAR systems are accurate only up to 1 millimeter or 1 millimeter, let's say, for the sake of discussion. But the texture or the quality or something that we want to preserve, there are maybe in sub-millimeter levels, maybe 0.5 millimeter, 0.2 millimeter. So because our resolution is 1 millimeter, we cannot capture that right now. So that's a limitation that we have. So we can't say it's a like one for all kind of a technique. There need to be iterations of this technique. So that's the immediate step would be to identify or have a proper discussion among the people who are working in this area to see what is exactly needed of the technology. So maybe LiDAR, when it comes to certain sites, might be much more useful than considering, let's say, another site. So maybe their optical imagery or SAR, synthetic aperture radar, might be more useful. So something like that is more important. We have to understand our current status and what exactly we can use the technology for right now is important. I think that a discussion is more important at the moment to know exactly what is needed, and then have a timeline of what is going to happen rather than like extrapolating on the things that we have.
Yes. So,
Right.
yes, that is about if is there any more questions? If our audience would like to talk and raise their questions, so you can raise your hand. Then we can unmute and give you a chance. I hope we don't have more questions.
I think, right.
Yes, yes,
Okay.
yes. And so that I would like to give you the vote of thanks. So actually, first I thank you very much, Engineer Dr. Sandun Dassanayake, for informative talk. And it is a timely talk and how to facilitate modern IT tools to preservation and also promoting our cultural heritage. Because actually we are country rich, we are very rich in cultural and natural heritage, and we have more than 2,500 history. So and in that history we have different traditions, different regional practices and different conflicts. So then we are having a very rich heritage where we can explore more. And then so as engineers, I believe that Dr. Sandun has highlighted the requirement of implementation of demanding and advanced developments based on IT tools to explore and protect our heritage. And then, because I'm doing the vote of thanks, so I should thank you very much, Dr. Sandun Dassanayake. And then I would like to appreciate all our participants who have actively engaged to the session today and make this event successful. And also I encourage you to join with us and with your ideas and explore the history in engineering view. And then I would like to express my heartiest thank to our IESL IT team for their continuous support for our forum, because we are having a island-wide spread members. So we are running everything is smoothly online because of you. So once again, I thank you very much for everyone who have joined with us. And with this, I officially conclude the today's session. Thank you very much.